Hi dears, good morning. Today we are going to discuss about the topic reduction of a quadratic form to canonical form under the matrices. Okay, so we have to reduce the quadratic form x square plus y square plus z square minus 2xy minus 2yz minus 2zx to the canonical form through an orthogonal transformation. First we have to write the given equation. The equation is in the form of quadratic form. So first step is nothing but first we have to write the matrix form. So the formula for the matrix form is the diagonal is nothing but coefficient of x square, coefficient of y square, here coefficient of z square. The remaining places are 1 by 2 into here coefficient of xy, here 1 by 2 into coefficient of xy. Similarly here y row, this is z row. So after that you have to find the characteristic equation. For finding the characteristic equation, we have to find out the value of S1 from the matrix A, where S1 is nothing but sum of the main diagonal elements and S2 is nothing but sum of the minus of the main diagonal elements and S3 is determinant of A. From this, we have find out that the characteristic equation is lambda cube minus 3 lambda square plus 4 equal to 0. So the next step is we have to find the characteristic roots. Solving these characteristic equation, we have find out the roots as minus 1, 2, 2. The next step is we have to find out the eigenvalues. For finding the eigenvalue, the formula is nothing but A minus lambda I into x equal to 0. We know the A matrix and I matrix is nothing but the unit matrix. For 3 by 3 matrix, the unit matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1 and x is nothing but x1, x2, x3. Multiply all these values and find out the equation. The first case is, so we have find out the eigenvalues are minus 1, 2, 2. First we have to substitute the lambda equal to minus 1. So substitute the value of lambda equal to minus 1 and frame the equation. Solve the equation by cross multiplication method. We find out the value of the eigenvector x1 equal to 1, 1, 1. The normalized form of this eigenvector is 1 by root 3, 1 by root 3, 1 by root 3. The root 3 is nothing but square root of 1 square plus 1 square plus 1 square. We get the value as root 3. So next case is the eigenvalue is lambda equal to 2. Substitute the value of lambda equal to 2 in the above equation 1. We get the equation. All the three equations are equivalent. So all the equations are equivalent means just we have to frame from this x1 equal to minus x2 plus x3. In this substitute x1 equal to 0, we get the another values x2 and x3. So we find out the second eigenvector. So next this matrix is a symmetric matrix with repeated eigenvalues. Therefore we use the LMN method for the case 3. In this case 3, just like the x3 value is LMN. The third eigenvector is finding from the two eigenvectors x1 and x2. Already find out the x1 vector is 1, 1, 1 and x2 vector is 0, minus 1, 1. Just to multiply these equations, we find the new equation and solve this equation by the method of cross multiplication. So from this equation, we have find out the third eigenvector x3 is 2, minus 1, minus 1. Next, write out the normal form. So the normalized form, next step is the matrix N is just write the first normalized form vector, second normalized form vector, third normalized form vector. From this next we have to find out the value of D equal to N transpose AN. We know N, just transpose it and we know that value of A. Just to multiply all the values we get the diagonalized matrix. The diagonalized matrix is nothing but all the elements are 0 except the main diagonal. The main diagonals becomes our eigenvalues. So the formula for canonical form is nothing but y transpose into n transpose an into y. Y transpose is nothing but y1, y2, y3 and we know the value for n transpose an. Just substitute the values and y is nothing but y1, y2, y3. Just multiply all the values we get the canonical form. So index is nothing but how many positive terms? Here 2 positive terms, the index is 2. Signature is nothing but number of positive terms minus negative terms. Here 2 positive terms minus 1 negative terms, we get 1. Nature is nothing but we have 2 positive and negative. Positive and negative are mingled means the nature is nothing but indefinite. Thank you.